So yeah, I guess I can start.
Sure.
Hi guys, this is the state of ZK plus Bitcoin at the Neil Foundation's Async house. Happy to be here with cool people. Um, I have 20 minutes, so it's going to be an interesting one because there's so much to talk and so much going on. And just a bit of myself, I'm a DevRel at Citrea. We're building a ZK rollup on Bitcoin with a trust minimized BitVM-based bridge. I used to be a protocol engineer, and then the team hired smarter people than me, so I switched. Now I'm trying to help people and also dogfooding our own product to see what we're missing. Yeah, there are some disclaimers, like I know stuff, and sometimes I also don't know stuff. And if you're confused, just ask me. If I don't know, I will say I don't know. If I have an explanation, I will do it. And yeah, we have 20 minutes, so this is going to be a bit fast. In case you stall somewhere, you can ask. In case your question has a long answer, let's talk later. So yeah, today's agenda is more specifically focused on Bitcoin side, and then like what's going on overall in terms of scaling. And I have some ideas on what is not good in the ecosystem. And obviously, from based on the context of this whole hacker house, it's going to be more in the ZK context as well, with a bit source. So yeah, scaling is basically what everyone's trying to do in almost pretty much all of the ecosystem if you're not working on privacy or some cool idea. Basically, many people are working on the scaling ideas. And EVM guys are trying to, Ethereum guys are trying to scale the L1 recently. So if you were to check the Bitcoin side, there are different ideas. So this is the Bitcoin L1 during some staking event, and the fees just jumped in a minute, like in a couple of blocks. And then people weren't able to use the chain. And yeah, not many people were super happy with that. When people are trying to use a system too much, that's common with the blockchains, it increases the price, increases all the communication. It's not super easy for machines to handle all this stuff unless they're hyper optimized or designed in that way. And like currently, Bitcoin is not really designed in that way. So the things that we can do to fix this is obviously initial idea is making better algorithms on Bitcoin wise, like fixing Bitcoin on itself, saying like we can do this algorithm in this way so that it can be much faster, and whenever more users come, things will be more stable and this kind of stuff. This happened in the past. We fought, like not me, but people fought for bigger blocks in the past. They somehow couldn't succeed and somehow succeeded. I don't know, it's different stuff. But everyone has their own opinion, and it's not like there is Ethereum Foundation or something. So people are very diverged in terms of the ideas that's going on the Bitcoin landscape. So we say like, it's obvious that we need to make bigger blocks and everything should be bigger and blah, blah, blah. But then when you ask the Bitcoin core devs, they say, no, it should be even smaller. We don't really like this. We want people to run Raspberry Pis, and it should go on this way. This was some mistakes. There's some shitcoins going on, blah, blah, blah. They're angry at us because we're trying to do some changes, trying to gather some consensus. And some people even have other opinions. But yeah, pretty much everyone has different opinions on just touching Bitcoin itself. It's a really complicated and slow process that I will talk more on. So yeah, apparently it's not a good way to do the changes to Bitcoin. So what if we do some other ideas? What if we run some other blockchains and stuff and do some connections of them with Bitcoin? One of them is obviously the payment channels, and Lightning is a great example of it. What happens is instead of doing transactions on Bitcoin itself, what we do is we use Lightning to say, I sent $5 to Dennis, and then Dennis sent $5 to Alex, and then the Alex sent $3 to him, back and forth. And we record all these on our own systems, but do not record directly on Bitcoin. And whenever we want to, finalize stuff, it's just like having a balance sheet between friends and then paying eventually. Whenever you want to pay eventually, you just get your amount into the Bitcoin itself. And even if you do hundreds of transactions, it's only one transaction that you want to go back to Bitcoin. That's the essence of Lightning. It works actually, but there are some problems with it. Like you cannot do much other than payments. And some people want to do more than the payments, obviously.
Is it fast enough?
Sorry?
Is it fast enough?
Is it fast?
Yeah.
I think it is somewhat okay, but when there are more Bitcoin usage plus when there is too much Lightning usage, it's problematic because let's say I want to send money to Dennis, but we don't have a direct channel, but you have a channel with him and you have a channel with me. And what I do is I send some money to you, like, no, you, it basically happens hypothetically that way. I send some money to you and then you send some money to him. But in the programmability way, the way it happens is not to make anyone losing money. You send to him and then you get it from me. This kind of stuff happens. So there needs to be people with liquidity, money, that are acting as the connections between different people. And if you cannot find good liquidity providers, then you cannot do anything you want, everything you want. And that's a problem. There are problems with Lightning. Like overall, it's a complex system. And there are still sometimes payments failing. Even like Trump trying to use it at some point and it failed on live stream and stuff like that, bunch of this stuff. I think I like it as a product itself, but it has some pretty obvious pain points. The up point is it's trustless, like people cannot steal your money or freeze it or whatever. You need to be awake for some stuff, but still, like it's a great use case. It lacks privacy as well, like kind of. Actually, there are some good developments, but some people say it's not enough. Anyways, Lightning was a good idea, but let's say what else? Like if I want to do some lending, borrowing, these kind of stuff, what can I use? One idea is sidechains, pretty popular, obviously. Just do a chain, and then claim that you have a connection with another chain in any way you want, and then you're a sidechain now. Yeah, there are different ideas to secure sidechains. Some people do merge mining. It's like they basically collaborate with miners. And some people do stake chains. It's like you stake some amount, and if you don't act right as a validator or something, you get slashed. There are different mechanisms at the end of the day. Side chains are like somewhat working mechanisms today, but theoretically they're not really secure. And most of them are really not definitely as secure as they claim.
So how do you say something like Stacks?
Yeah, Stacks is a side chain. It's just a chain, I mean. And
it's like the stake chain, the later one?
I'm not super sure,
Okay.
but Stacks is a sidechain basically. And one common problem with sidechains is, so you have a connection, and if you're a Bitcoin sidechain, you have Bitcoin as the asset. And how are you going to claim your Bitcoin in this new chain? So let's say I have 5 Bitcoin, BTC. How do I move my money into this new chain? Then the bridges came around, like you use bridges basically, and there are different types of bridges. One idea is obviously federations. What happens is there are 10 people with money, and you basically trust them. You send your money into them, and 6 of them, let's say, can move the money in any time they want. Actually, currently it's the most used version of BTC asset is 3 to 5. You trust 3 people out of 5 to move your money. And that sucks. Yeah, that's the wrap Bitcoin. And there's also drive chain ideas. It's a bit complex to go here, but you collaborate with miners again, they vote and stuff like that. And there's also the staking stuff, but they're not really super capital efficient. And you can also alternatively have your own tokens, just like everyone in the industry, which is not an idea that I am a fan of, because tokens are sometimes shady a lot. Yeah, sidechains basically are chains, okay. But let's say you are a user of sidechain, then the sidechain can even block you from the RPC level. Like every node in the sidechain or sequencer or whatever can basically stop you from moving your fund from A to B because they're in control. And more often than not, there's no guarantee that they enable you to do whatever you want to do. They can censor you, and there's also trust problems. They can steal money and blah, blah, blah. So we're not really huge fans of sidechains. So does Bitcoiners, to be honest. And then the idea of rollups comes in. So the difference of rollup between a sidechain is rollups are posting data in any form into another blockchain. And you say, as long as that another blockchain is secure, then this chain, this rollup itself is also going to be secure. In the Bitcoin case, you send your data into Bitcoin, And then as long as Bitcoin is not reorged heavily, which is a catastrophic scenario for the whole industry, then your data will always be available to Bitcoin. That means you can always check the Bitcoin to sync with all these machines. And if you can also put some forced transaction mechanism, then you also bypass the censorship. And now you basically make another source of truth for your own chain so that people can trust you more. And as long as Bitcoin, again, does not reorg or something, you cannot change your state because it is there. Otherwise, what you need to do is have some really social consensus stuff to persuade everyone in the world or stuff like that. Yeah, basically, rollups inherit security from the other chains, and there are optimistic rollups and ZK rollups. You cannot do optimistic rollups on Bitcoin because Bitcoin block size is 4 megabytes. And yeah, and people say you need to drop it to 300 even sometimes, as I showed. And also, even if you put the transactions, then the bridge is also still a problem. You cannot do verification stuff. There are a bunch of problems, essentially. If you try to submit all the data from your transactions into Bitcoin, then you cannot, basically. Like if for one user, it's okay, but for 100 users, 1,000 users, 10,000 users, it's really bad. And then if we can't do optimistic rollups, then the other idea is basically building ZK rollups on Bitcoin. So what you can do is, as an alternative, you can post ZK proofs so that people can use and verify it. And you can also post some data off your chain as well in the state difference form. The way it happens is, instead of putting all of your data, all of your transactions line by line, what you do is you take from a block checkpoint A to a block checkpoint B, and there are obviously two Merkle trees, and then you basically post the differences of these interval.
State diff.
Yeah, state diff, exactly, of this Merkle tree, and then you're basically still able to sync. And in that sense, you need a sequencer who orders the transactions and basically determines the blocks, and you need a prover who basically proves the execution of your chain using possibly circuits or ZK VMs. But then again, the same problem is here. Like, how are you going to move your funds into the other chain? Are you still going to trust anonymous majority, federation, 3 of 5? What are you going to do? That's essentially like the major problem today. So that's also where ZK comes in. So like if you check the ZK proof systems, there are like two major of them, Starks and Starks. Starks are really cool. They're unbounded computation-wise. Their size also grows as the execution becomes more and more. That's a problem because the more data you post on Bitcoin, the more expensive it gets. They both like negligible in terms of verification. There's a trustless setup difference and blah, blah, blah. But like there are some mechanisms that you can use. And these really come into play. And the way it happens is like you can basically prove the execution of your chain in the Starks. You can use Starks to say, this has been the execution of block A to block B, and then this is the program that does this for block A to block B, and I ran this in a ZKVM environment, like RISC-0 or SP1, or a custom one, like, I don't know. Even Valida, I really find them nice.
But I think RISC-0 will run a final run snark, right? Like right after the Starks.
Yeah, exactly. And then what you can do is you can use Starks, and then you can do the Stark to Snark converter. So you can just map your Stark proof into the Snark proof and then post it in a 192 byte or something, so that you do not publish kilobytes of data. Instead, you just publish bytes of data, which is much, much better. Yeah. There's obviously the concerns of obvious ZK sounds and stuff, but the probability space is high enough to ignore, I believe. And we may see much better solutions.
But there are two parts, right? The proof and the data.
Yeah, exactly.
So I think data is going to be megabytes.
Yeah, I'm going to go there.
Okay.
Yeah. Yeah, with the setup, like, assume that there's no bridge. With this setup, you now put your data and you also put the Snark proof of the execution. Now you're a sovereign ZK rollup.
Oh, yeah.
A chain on its own, living sovereignly.
How do you define the sovereign rollup? That's always something.
I would say you can just use the DA chain, like in this case Bitcoin, as the source of truth. And if people want to build bridges, let them build it. You don't touch it. Like there's no specific canonical bridge, and you may build even light clients for the verification from the DA layer as well. so that people can even verify the latest state from their mobile devices and stuff like that.
So you guys are using Bitcoin as a DA layer?
Exactly. We post the data on Bitcoin.
I mean, there's a new company called Newbit.
Yeah.
They're also sort of doing their own
Yeah,
DA.
but then you then trust.
What's your opinion on that?
Yeah, opinion is you then trust Nubit
Oh yeah.
versus Bitcoin.
Yeah.
And even for the if you, even the Ethereum has bunch of different ideas, and they have this different social opinions among people. And if you check security-wise, it's either Bitcoin or Ethereum that are leading. And let's say Celestia is a cool chain, but then I don't know how long Celestia will be around, and I don't know how long they will survive. If I use Nubit, I don't know, even though they're cool people from Berkeley or something, I don't know how long they will be alive. And I want my chain to be continuously alive and inheriting the security from a good chain. And Bitcoin is arguably the safest chain in the world in that sense.
But I mean, there is a reason why they're using Bitcoin as a base settlement layer, right? That's what you're saying.
Sort of. I will come into this again.
Oh, okay, go ahead.
Yeah. And then this is sovereign rollup, but then it's also not very easy, as you said, the diff size. Based on the benchmarks, it turns out to be not the megabytes, but hundreds of kilobytes. And even in the congested rollup usage, what we saw was we are able to keep it under 400 kilobytes per Bitcoin block. But let's say even if it exists, it only delays the finality. So we can always publish it in the form of 400 kilobyte transactions. And the chain will continue to work. It's just that finality delays on its own. Because the finality is essentially at the point you cannot change any data. And this is 6 blocks of Bitcoin. And let's say we were a bit late to submit the data from block A to block B. And then that means the finality of block A to block B is delayed a bit. But still, it's going to be eventually secured by Bitcoin. Yeah, but still, is it cheap? No, obviously. We're going to pay probably thousands of dollars per Bitcoin block.
But one thing is that I mean, that makes sense. Megabytes may work fine because each block has 4 megabytes, right?
Yes.
And OP return is 80 bytes, and you can put your proof there
Uh-huh.
and data on the other blocks. But I mean, for instance, if you guys want to do liquid rollups like an exchange, right, like Uniswap, right? If you want to do that, that's going to be crazy.
Yeah.
Even you have this use state.
Yeah, and I mean, for example, on our end, we set the blocks to 2 seconds and set a custom block gas limit so that the diff size do not increase too much.
Oh, okay.
Yeah, that's important. And why are we even doing this is another point, and it is that there is a demand for it, basically. With the recent price action and with all this stuff going on, there are really certain institutions that want to use these Bitcoins, or even whales that want to use these Bitcoins as a revenue stream without compromising their security too much. And they obviously cannot trust the side chains enough. And rollups are great for this. But the problem is not more than 3 arguably rollups can survive because of the fee market of Bitcoin. So there's going to be either 1 or 2 at most. And even technically, I see 1 or 2 teams capable of building this stuff. And yeah, people are really going over what can be built through using rollups. And this is partly also because of the bridge that I will come to. This is a report from the Galaxy, from Gabe Parker. He was about to be here, but he couldn't make it due to some problems. Yeah, we will post some nice data to Bitcoin. And there's also the bridge design that I will talk over now. And this happened actually a couple of days ago, I would say. I was in one of the Bit devs, and I was talking with Bitcoin core devs, talking about BitVM and how this stuff going to work. And then I specifically told them we may publish hundreds of kilobytes of data to Bitcoin per block even. And then this was the exact reaction we get.
Great for miners.
Great for miners, but not great for the people who wants to keep the chain cheaper by using it as a gold, which I hugely oppose. But everyone has their own opinions. I think it shouldn't be a store of value. It should be cash, electronic cash. People have different opinions. I don't know. Yeah, but yeah, this was exact reaction that we get, and they basically told me not many people are going to like that. But anyways, it's permissionless. Yeah, so it will work. We're shipping it. It will work in Q2, Q3, hopefully. We're going live on mainnet, and like we will see. But then the same problem is also here again. How am I going to move my Bitcoin into this chain? Am I going to trust again WrapBTC 305? Like, I don't want to name names, but I will name names. Am I going to trust Justin Sun? I don't want to do this. And can there be a better way of using ZK bridges? Can you even verify a ZK proof on Bitcoin script? The answer is sort of, like, because you cannot verify a proof directly. It's not like if you're using EVM or if you're using just any other tooling like Rust or stuff, you can just use libraries and then put your proof and then it will say yes or no directly, bam, it's done. On Bitcoin script, you cannot do that. Bitcoin script is not Turing complete. It's quite like Turing incomplete script. And you cannot do trustless proof verification just by putting some proof and whether checking this is correct or not. And there are some people saying otherwise, saying like, oh, we made the trustless Bitcoin verification. They're just a bunch of clowns, so just don't trust them. I'm not going to name names, but you will probably see it eventually. They're lying. There's no trustless proof verification without a change to Bitcoin. Anyway, skipping these clowns. The main problem is, let's say snarks, or with the tricks, what we can do is we can use BitVM. Actually, this should be on the next slide. So the idea is BitVM, essentially. What you can do is, you still cannot verify Starks, but what you can do is, you can verify snarks optimistically. The idea comes in the form that in a series of transactions, you basically treat a snark proof as a fraud proof. It's like you basically you can publish a snark proof and then challenge it using Bitcoin script. And the way you do it is, there is a snark verifier written in Bitcoin script in around 1 gigabyte, because there's no multiplication even in Bitcoin script. If you want to do 8 times 9, what you need to do is 8 plus 8 plus 8 plus 8 plus 8, blah, blah, blah. There's no multiplication, there is no pairing, a bunch of stuff. So still doing all these interesting stuff, you're able to write a snark verifier of 1 gigabyte text file, but then you cannot put the 1 gigabyte text file into Bitcoin block because it's 4 megabytes. What you do is you basically split it in chunks and then build a tree of them with inputs and outputs, and then you commit to it into Bitcoin script. And then if something goes wrong, you basically challenge someone to provide you a snark proof, and then saying that, for this particular proof, I think your proof is not correct, and it will be falsified in a series of transactions. So the idea is you're treating a snark proof as a fraud proof in Bitcoin script. You're saying that this part of this proof, like this part of this verifier, will going to say this proof is wrong, and you're not doing your job correctly. And because that we can do it, we can do optimistically verified ZK proof mechanisms, and using them we can do ZK bridges using BitVM. And it's extremely complex, I would say. People are working on it for more than 1.5 years. And now using this idea, what happens is the bridge is, there's, let's say, n of n multisigs of 200 people. And there's also the script modified in the sense that you can also challenge someone on chain out of these 200 people. And when you want to enter and exit into a chain that uses BitVM, what happens is when you want to exit, these people first pay you from their own pockets. And then if they don't pay you, then you can challenge them with the Bitcoin proof of work on Bitcoin script. And then they get slashed and kicked out of this. So essentially all the idea comes down to you only need one of these people to be honest and functioning and pay you so that all this stuff continue to work. Compared to 305, you have 1 of 100, 1 of 200, only being honest.
So these guys are like middlemen.
Sorry?
And they are like middlemen? Like
Middleman?
money.
Yeah, it's kind of like this. Let's say I want to enter the Citrea. The way it happens is I send my money into an n+1 to n+1 multisig, and then they take it from here by my consent. And I basically, when I move into the n of n multisig of them, my money gets minted. Basically, you can trustlessly mint it on the chain just by providing the proof that you did the transaction. And when you want to exit Citrea, you basically submit an exit request, and then they fulfill your request. And then 2 days later, they get the exact same amount that you get from the multisig automatically by inscribing some data. And
Who are those guys? Like, to be the middleman?
it's to be determined. Probably Galaxy and Founders Fund and some other market makers and some token issuers. I don't know, but the hype is there because they're going to collect the sequencer fees and stuff, and it's going to be some nice money for them. And they don't lose money. It's just that they need to first pay and then later get automatically from the chain. And the whole idea basically comes down to, instead of trusting 3 people out of 5, you now have a setup that requires you to only trust 1 out of 100, which is like colossal improvement. And you cannot do better than this because there's no trustless verification of ZKPs on Bitcoin. You cannot do it. So this is like theoretically the best one you can get today in the model. And it's possible due to the BitVM, thanks to the BitVM idea. And even if you there's something wrong, let's say you wanted the exit and they didn't pay your money, anyone in the world can challenge them and slash them. It's just permissionless challenging. So all the pain point comes down to 1 people out of 100 being honest. That's it.
That's the BVM2's idea, right?
Yeah, that's the BitVM2. And BitVM2 idea is developed by BitVM Alliance. There's us, there's the another rollup guys, and there's also some guys who trying to build bridges to EVM sidechains, from Bitcoin to EVM sidechains. There's 5 or 6 companies. It's a collective effort. It's almost finished. BitVM implementation is almost finished, and we're also almost finished on our bridge design as well. And yeah, we've been working on it for like 1.5 years with a team of 10 researchers, or I don't know.
There is this thing called like these snarks.
Yeah.
Do you know them? Like,
Yeah.
what's the difference there? I'm kind of confused now.
Yeah, BitSnark is the idea of Bitcoin OS, and to be honest, they don't reveal too much. They're also building something similar, a bit customized version of it, but we don't have the recent updates from them. And they've gone into interesting ways of working with Cardano, and also saying they built the trustless verification, which I don't really like a single bit.
Yeah.
And we will see. Good luck to them. But yeah, they're not in the alliance. They're just doing their own stuff.
Yeah, I heard the news like Cardano, like they said like they're willing to be the layer 2 of Bitcoin.
I don't know.
Something like that.
Interesting strategy, but it's their end. So
Yeah. And their price goes like doubling in 1
Yeah.
year or something like that.
I would like them more if they stop saying trustless. That's
Yeah,
it. So yeah, this whole BitVM idea is quite complex. It's almost like Rube Goldberg machine, and it could be much better if we had new opcodes in the Bitcoin ecosystem, like OPCAT for building Merkle trees, or even OptZKP. But then, if you even mention these, then we get into a fight with pretty much everyone in Bitcoin ecosystem. Like it's 2025, and people have no idea what's going to be activated. There's a push for every single opcode on that could be possible. And yeah, it's like I talk with people. Some people say opcat enables MEV on Bitcoin. Some people say it's more of a shitcoiner's psychological pressure on Bitcoin. They don't want it a single bit. And then when you offer even alternative opcodes, that could be nice. It's just that everyone has a different opinion, and no one comes to the conclusion of others. So it's just Twitter fights going on all overall. I think we may get an upgrade, but I have no idea which one it's going to be.
The OPZKP is very interesting.
OptZKP could be nice. I mean, I could just build a rollup. It would be great. So there are some problems. One is using Bitcoin SDA is not the great way. We're going to probably pay a lot and burn a lot, which is natural. And also, if the Bitcoin L1 fees increase, the people using our rollup will also pay a lot. And we need more users to divide the cost on them. So we need to hit it nicely, which is a whole another challenge, but we're down for it because there's a huge demand. And You can do validiums. You can do basically a Celestia rollup, but then you trust Celestia to be continuously alive, which is maybe a good scenario, but I don't know. Like, you basically trust Celestia, and not everyone wants to trust Celestia compared to Bitcoin. You can make adamantiums. It's a bit too different. I don't want to dive into that, but you essentially keep your state on your own and then interact based on this. And the last idea that we're going to pursue after mainnet is devolution. You're able to use two different DAs at the same time, and you have two different trees for each DA. And then your state tree is basically a combination of them. Yeah. And if you use Celestia, for example, you're going to pay less, obviously, but then you're going to trust Celestia. Yeah, but this is like pure R&D. So this is an idea coming from, I think, the Starkware guys, but there is no known implementation known to man, I believe. And also, like another thing is everything's super new. Like we started to build Citrea, I think more than 1.5 years ago, and there was almost no one working on these kind of ideas. Like the market was idle, and people had much skepticism, and also BitVM wasn't there, so no one knew how to do the bridge. We had different signer ideas and stuff like that. And then BitVM came. Now we can do one-off and trust assumption bridges, which is even better than Ethereum bridges because they have also the honest majority on their own. But yeah, everything is rolling out. But we're really close to mainnet and the bridge implementation. Hopefully, we will get trust minimized bridges on Bitcoin itself, and using ZKPs as well. Yeah. So now. Like prior to that, I also talked about the general state of industry. On our case, the way these things work is there's basically the R chain going on the below level, and we basically publish blocks in every 2 seconds, and then sequencer basically sends batches of these blocks into the prover, and saying that okay, you prove these, and then just publish this verified data into Bitcoin. So that people can just fetch from Bitcoin and also verify the execution, so that now it's proven. And after 6 Bitcoin blocks, it's finalized. And on that end, like a sequencer also publishes a sequencer commitment until this data is published. The order does not change, so that you become finalized in the order of the transactions. You can just run a full node, which reads Bitcoin and then checks, compares to this, and then basically accept this as a source of truth. And again, the whole point is as long as Bitcoin does not reorg 6 blocks, which will be a catastrophe for the whole industry, the data will be there and you can just sync using Bitcoin stuff. And yeah, also like decentralizing prover is not that hard. There's already going on multi-prover effort in our team, but I think we're not going to ship it before mainnet. I don't think so. Decentralizing sequencer is obviously everyone's word, so there's a time for that. And on the bridge side, the way it happens is we continuously publish proofs of execution. And then when you want to exit the system, you just request, and then people pays you and then gets it from an NFM multisig automatically using the complex script setup. And in case someone becomes malicious out of 100 people, then anyone in the world can challenge them and slash them on Bitcoin script directly using Bitcoin Light Client proof with a proof of work. And using this way, you get a bridge design, which is not 3 of 5, which is not 6 of 10, or 9 of 11, or blah, blah, blah. You now have 100 of 100 multisig that your money is always in, and you can later claim by only having 1 people being honest using the Bitcoin script. It's not easy, still almost finished, but it's been a long effort, and it's also a bit hard to explain as well. But this is probably the best one you can get with BitVM stuff. And what's next is basically obviously decentralizing the sequencer stuff. I think this one is the first one that we will look for because the chain itself will not be cheap. Everything is on Bitcoin. Paying thousands of dollars per Bitcoin block is going to increase the L2 costs a lot. We're looking for alternative proof systems and multi-provers. More VMs are actually, there was before me, the Fluent guys were doing a presentation. I'm quite bullish on them actually. I'm looking forward to see what they come up with. In case it becomes successful, we may pivot as well. but I think it's really a long shot. One thing that's not really a long shot is the L3 idea. So now you have a Bitcoin asset on EVM, which is trust minimized, rather than wrap BTC or TBTC or something like that. Then what you can do is, if you can build cheaper systems that have direct access to this trust minimized Bitcoin asset on EVM, then you can just use it for dirt cheap and in any way you want. And we're actually quite experimenting with this. You can reduce the execution costs of the rollup hundreds of magnitudes of order, and you still have the access to one of untrusted summited Bitcoin asset on EVM chains. That means if you have, let's say, $10 million, now you can move it to one of untrusted summited EVM chains, and then for, I don't know, 1 cent, 2 cents, you can just use any lending borrowing protocol or any other stuff that you want to see in the EVM chains, which is actually the main reason that we're building all these, because there's a huge demand again. Like, we talk with people, there's a huge question of when mainnet, when it's coming, like different ideas. We believe like this is going to be huge, and that's why we're fully committed to it. For the future also, if the Bitcoin upgrades with the OP-Cat, which I think it's going to take us a lot, we can just do trustless L2s without 1FN, without anything. You can just enter and exit whenever you want. Like this is pretty much almost proven that you can do it with OP-Cat. And everything becomes much more easier. Now you get like, is it stage 2? I don't think so. But still, like, you can get trustless chains, just like Lightning, where you can enter and exit whenever you want, if you get OP-Cat. And if you get OpZKP, it's even better. If you get pairing opcodes, probably BitVM is going to reduce the costs really, really much easier. Again, like Bitcoin script does not even have multiplication. If you want to do 8 times 9, you need to do 8 plus 8 plus 8 plus 8. And that's the specific environment we're trying to verify snark proof for 1 gigabyte of Bitcoin script. And another idea is doing sharding-like stuff. But I think Bitcoiners have no idea what this is, unfortunately. And even if they have, they're probably going to assume that they don't want to do it. Pretty much every single point here is going to become this meme that we always came up eventually every time. I hope we will get something nice as an upgrade, but I think it's going to take too much time. Yeah. And given that it was ZK plus Bitcoin intersection, this is my last slide. There are also some other ideas going on. And the first one is bringing some more privacy into Lightning. There is some, but still Lightning is more than desired traceable in many aspects. And if we can add, ZK proofs into it, there are some ideas going on to make more private Lightning so that people are not moving to Monero. The idea is going on. There's also the idea of soft pipes, kind of emulating OP-Cat stuff. Actually, it's been invented by Misha, who is the old CEO, ex-CEO of NIL. But it has its own trust assumptions. There's also the Bitcoin consensus proof idea, like the Starkware guys are building Shinigami with Cairo. The idea is, when you sync with Bitcoin, what you do is you replay the whole chain all the time, which takes unfortunate amount of time. If we can basically do the consensus proof of the script of the Bitcoin, then you can just download the state with a simple proof and then verify it and then continue from there. I think this is really close to finish, but we're looking for an implementation with Rust, with actually the kind of work as an R&D off the record, because this may also be super useful for us, because our full nodes are also syncing with Bitcoin all the time. But yeah, the more alternatives are obviously better, because let's say one proof system screwed out at some point, there's a soundness bug or something, then we can always continue with the other one, which is better. There's also the idea of atomic swaps with privacy pools. Prior to this, we worked on Railgun, pretty much. One idea that people can use is you can do atomic swaps from Bitcoin to EVM and EVM to Bitcoin with enough liquidity on both sides, obviously. But then on the EVM side, when you get the money, you get directly into your privacy pool, so that it's not traceable anymore unless you withdraw it instantly. This is actually quite a nice idea that I look forward. We've been talking with 1, 2 guys, but I don't know if they're going to build it. Yeah, this is the whole extremely not so easy talk. So thank you for listening. If you have any questions, I can take, or we can chat later.
I do have a question.
Yeah, please.
Maybe it's complicated.
Mhm.
I didn't really understand how the CK proof, after the fixed challenge, how you settle a challenge. Is it like a naysayer proof? Is that a similar idea? You know?
I don't know about naysayer proofs, but also like I'm not a ZK researcher. That's more of my understanding. I used to work on the client beforehand. Like I worked on this stuff pretty much for a year, but I didn't work on the bridge. But as a more explanation, from what I understand, how it works is, so actually there's not something that enforces the bridge operators in the L2 side. So it's not like just like every rollup, like if the bridge screws up on the Arbitrum, what happens? Does Arbitrum stop or does it continue?
Yeah, sure.
Yeah, so the idea is there's this 1 gigabyte of Bitcoin script, and then you chunk it into 4 megabytes, and then you build a Merkle tree of them. And then when you see that one of these operators are behaving maliciously, what you do is you basically reveal the path of the program that's going to say this part of this proof verifier will say wrong to the specific snark proof.
Yeah, basically you just essentially dissect until you find
Yes.
part of the proof that fails verification. Okay,
Yeah.
It's the same idea as
Yeah, you run it off chain and then you see where it blows up and then you just challenge it there. The way it happens is actually, if everything goes correctly, you don't touch it at all.
Yeah, no, of course.
And then if something goes wrong, what happens is me, as an honest person, provide a Bitcoin light client proof with a certain proof of work, and then say that I bet you cannot do better than this. And then if they try to provide a false proof, then they get also fucked up on the specific part of the verifier.
Thanks.
Yep, I guess that's all. So thank you.